Hello everyone, welcome to my channel J Networks and Technologies. In this video, we'll learn about Transmission Control Protocol or TCP. In the previous video, we have seen about the layer 4 of TCP IP protocol. In this video, we'll go in depth about how the Transmission Control Protocol works at header level. So on the screen, what you are seeing is the header of TCP. In this, you see the first 4 bytes are left intentionally. After that, the first field is the source port, the second one is destination port, third one is sequence number, fourth one is acknowledgement number, and the other fields that are offset, reserved, flag bits, window, checksum, and urgent, we'll discuss them in another video explaining in great detail. So each TCP IP application typically chooses to either use TCP or UDP based applications based on their requirements. For example, TCP provides error recovery, but to do so, it consumes more bandwidth and uses more processing cycles. At the same time, UDP does not perform error recovery, but it takes less bandwidth and uses fewer processing cycles. Regardless of which of these two TCP IP transport layer protocols the application chooses to use, we should understand the basics of how each of these transport layer protocols works. So if we are a protocol designer or an application designer, we need to know what is the protocol we need to apply in our programming language based on this knowledge. So TCP was first defined in the RFC, request for comments, and the comment number is 793. So TCP relies on IP, Internet Protocol for end-to-end delivery of data, including routing issues. In other words, TCP performs only part of the functions necessary to deliver the data between applications. Also, the role that it plays is directed towards providing services for the applications that sit at the endpoints. So, the role of TCP is end-to-end. That means, let us say this is sender computer and this is receiving computer. The goal of TCP is to make the applications present in the sender computer and applications present in the receiving computer to make them communicate end to end. Regardless of whether two computers are on the same Ethernet or they're separated by the entire internet or wherever these two sender receiver are present, the end goal of TCP is to make sure that the applications sitting on them are communicating to each other. For example, the sender would be sitting in the US and the receiver would be sitting in on the other end, let us say he's sitting in the Japan. But the TCP makes sure that both of them are communicating end to end and there is no loss of data. So before moving into the next important function of the TCP, that is multiplexing, I'll briefly explain the fields in the TCP header. The first one is source port. The source port is the port number that will be used by the sender while sending a data, and the destination port will be the port that should be present on the receiver side. And this is the sequence number. In my previous video, I have explained how the TCP sends packets and then attaches a sequence number to it so that it can note down those sequence numbers, and then if any packet is missing, those packets will be reassembled. So the sender will attach a sequence number, for example, 1, and send it to the receiver, and then the receiver will in turn send an acknowledgement for this sequence number and adds its own sequence number and its acknowledgement number and sends it. So these fields will be present in sender and receiver's TCP packets. So the offset, reserved, and flag bits, we'll discuss them great detail in other video. And the window is the one which helps in flow control, flow control or windowing. And checksum is the data. So this checksum calculates on this whole TCP header and then calculates and gives us one checksum number, let us say 1, 2, 3, 4, 5, 6. So this is just an imaginary number. While this checksum will be updated here, this number will be put here. So when the sender calculates this checksum, it will be updated 1, 2, 3, 4, 5, 6. And when the receiver receives this TCP packet, and then it calculates its checksum, and it should get the same number. So that means that the data is intact and it is not tampered. So that is the reason checksum field is here. And urgent flag, if this flag is set to on, if it is 1, 1 is on or 0 is off. If it is on, then in the receiver's buffer, if there is any traffic or if there are any packets already present in receiver's buffer, those buffers will be bypassed, and then this particular TCP packet will be put in front of the queue, so that that will be treated as urgently. So this is a brief about the header fields of the transmission control protocol, or the TCP protocol fields. Now let's move on to one of the important functions of the TCP, that is multiplexing. So in my previous video, I have explained how multiplexing works briefly. In this video, we'll look into great detail about how multiplexing works. So both TCP and UDP use a concept called as multiplexing. Multiplexing by TCP and UDP involves the process of how a computer thinks when receiving data from another computer. The computer might be running many applications such as a web browser, an email package, or an internet uh, VoIP application, for example, Skype. TCP and UDP multiplexing tells the receiving computer to which application to give the received data. So let us assume an imaginary network. Let us assume there are two computers, and we'll have an example of communication between these two computers. Let us say this first computer is used by Hannah and second computer is used by George. So Hannah uses an application that she wrote to send advertisements that appear on George's screen. So she has written an application that sends up ads on George's computer. The application sends new ad to George every 10 seconds. Hannah uses second application, a wire transfer application, to send money to George. So this is another application that she uses to send money to George. So this is a wire transfer application, wire transfer. So at the same time, Hannah also uses a third application to connect to George's PC, and then she browses the website hosted on George PC that will be running on port 80. So there are currently three applications that are connecting from Hannah's PC to George PC. The first one is it's an ad application that shows ads on George PC. The second one is a wire transfer that sends money to George, and the third one is just a browser that's trying to browse the website present on George PC. So let us see this example using an image so that it will be very clear when you try to understand the process happening between Hannah and George computer. So in this picture, we see that George is running three applications on his computer. The first one is an UDP based add data. The second one is TCP based wire transfer data, and third one is same TCP based web page data. So George needs to know which application to give the data to, but all the three packets are coming from the same Ethernet and from the same IP address of Hannah. So we might be thinking that George could look at whether the packet contains a UDP or TCP header, but if you see in the figure, the two applications, wire transfer and web, they both are using TCP. TCP and UDP solve this confusion or this problem by using a port number field in the TCP or UDP header, respectively. Each of HANA's TCP and UDP segments uses a different destination port number so that George knows which application to give the data to. For example, let us assume the sender side, the source port could be some random number like 25,535, and the destination port could be 30,200. So if George has already enabled that add application on his PC, this 30,200 will be already open on his PC or the server. So as soon as the TCP packet is opened on George's side, he would open the TCP header and see that, okay, this is the destination port. So I should move this packet to that application, that add application, and add application will take care of the rest of the application activities. In the same way, let us assume Hannah is sending the wire transfer data using some random port 56,000 as the source port, and the destination port may be 25,000. So if the wire transfer application is running on George PC, so that George will receive the TCP packet and send that packet to the wire transfer application, and wire transfer application will take care of the other application activities. The same way, the source port would be some random port like 26,000, and the destination port would be 80, because 80 is the universal port for web applications. If the web application is running on George PC, the packet would be moved to web application, and the web application will respond to the receiver, sorry, to the sender in same way. So this multiplexing relies on a concept called a socket. A socket consists of three things. First thing is an IP address. Second thing is a transport protocol like TCP or TCP or UDP, and third one is a port number. So all the three would make up a socket. So for the web application on George PC, the socket would be the source IP address of Hannah's PC, and the protocol would be TCP, and the port would be 80. So these three would become a socket. When Hannah's web browser connects to the web server, Hannah uses a socket as well. Possibly like the HANA PC would have a source IP address, the protocol would be TCP, and then the port number would be the random port number 26,000, which we mentioned here. So this is another socket on HANA's side. So by this, there are unique sockets formed at the sender and receiver PCs. So as we mentioned, these are the port numbers which are randomly assigned, and there are well-known ports. There is an organization called as IANA, Internet Assigned Numbers Authority, the same organization that manages IP addresses allegations worldwide. It subdivides the port number ranges into three main ranges. The first two ranges reserve numbers that IANA can allocate to specific applications and well-known application, while the third category reserving ports to be dynamically allocated as used for clients. So the first one is well-known ports. The first category is well-known ports, and the numbers are 0 to 1023. So these are reserved ports. Numbers from 0 to 1023 are assigned by IANA with a stricter review process to assign in new ports than user ports. The second category is user ports. These numbers range for 1024 to 49,151. These are assigned by IANA with a less strict process to assign new ports compared to the well-known ports. And the third category is ephemeral. or dynamic. So these are the numbers from 49,152 to 65,535. These are the ports that are not assigned to any of the applications, and they are intended to be dynamically allocated and used temporarily for a client application while the app is running. So, for example, our ports, the sender ports would be from these three ranges. This range 49,152 to 65,535 as a source port, because mostly they are not used by any applications and there would not be any clash while these are used as a source ports. Whereas if the destination ports are assigned between the well-known ports or user ports, they would be put in the destination socket. So let us see this with an picture example so that it would be really easy to understand how these ports would be allocated. So this particular image shows an example that uses three dynamic or ephemeral ports on the user device on the left. This is the user device with the server on the right. So this is the server. The server is using two known ports and one user port. The computers use three applications at the same time. Hence, three socket connections are open because a socket on a single computer would be unique. A connection between two sockets should identify a unique connection between two computers. This uniqueness means that we can use multiple applications at the same time, talking to applications running on same or different computers. So multiplexing is based on sockets and ensures that the data is delivered to the correct applications. As you can see, so this represents one socket. So this socket information consists of the source IP as 10.1.1.1, and this is a UDP protocol, and the source port is 49,159. And the socket on the server side is 10.1.1.2 with the UDP as the protocol and 800 as the destination port. So this represents our imaginary ad application, that is port number 800. Whereas the second application using the same source IP address 10.1.1.1 and it is using TCP as the protocol, and the source port is 14,153. On the socket on other side, the destination IP address is the same thing 10.1.1.2 and the protocol is TCP and the destination port is 9876. So while we see that the third one is TCP application and the source port is same and the destination port and the protocol is same on the server side, these both the computers are able to differentiate their applications based on these port numbers, source and destination port numbers. These are different. So this is called as multiplexing. In this way, the computers, they are not confused even they receive the packets from same IP or using the same protocol. Based on the port numbers, they exactly communicate each other back and forth using these port numbers. So port numbers are a very important part of the socket concept. Servers use well-known ports or user ports, whereas clients use dynamic ports. Applications that provide a service such as FTP or Telnet and web servers open a socket using a well-known port and listen for connections on those ports, because these connection requests from clients are required to include both the source and destination port numbers. As I explained in the TCP header, the TCP header has both source and destination port numbers. The port numbers used by the servers must be known beforehand. Therefore, each services uses a specific well-known port number or user port number. Both well-known and user ports are listed at the IANA website. You can search in Google for IANA and then you can find out the port assignment, and then the same website lists the IP address allocation and assignment throughout the globe. On client machines where the requests uh, start or originate, any locally unused port number can be allocated. So the dynamic port numbers, which are hired port numbers, they can be used as source port numbers. The result is that each client on the same host uses a different port number, but server uses the same number for all the connections. So let us say this is port number 80. For example, uh, the same user opens another browser, and in that browser he tries to access the web server running on the server. So the packet source would be 10.1.1.1, and it would be a TCP protocol, and the source port would be some random port in the dynamic ports list. Let us say, for example, that is 52,535, and the destination would be the same, 10.1.1.2 TCP and 80. So these two, this is one traffic going for web server, and this is the second traffic. These are differentiated using the sockets, using multiplexing. So by this we can understand that not only two connections from the same host, even 100 web browsers on the same host computer or the same source computer could connect to a web server, but the web server with 100 clients connected to it would have only one socket. This is the only one socket on the server side. Therefore, only the one port 80 would be open and it would be listening. The server can tell which packets are sent from which of the 100 clients by looking at the source port of the received TCP segments. The server can send data to the correct web client by sending the data to the same port number listed as a destination port. So while the server responds, it responds two packets. The first packet would be source port as 80 and the destination port would be 49152. So it will go to one browser. For the second web browser, the server responds with the same port number 80 as the source and destination would be 52535. So that packet would go to the another browser. So the combination of source and destination sockets allows all participating hosts to differentiate between the data's source and destination. Although although this example explain the concept of using 100 TCP connections, the same port numbering concept applies to UDP sessions as well, because UDP will also have a header with source and destination port number. So this is a brief about the communications that happen through TCP transmission control protocol. Hope this video was informational to you guys. If you like this video, please like, subscribe, and share this video. Also subscribe my channel. Thank you for watching.